Hey everyone, I am Sanal and welcome to OmegaCodex channel. And today we are talking about minimal APIs in .NET. A minimal API is a way of creating HTTP APIs with minimal dependencies and code. We all are familiar with the controller-based approach for APIs in .NET. ASP.NET supports two approaches to creating APIs, a controller-based approach and a minimal API. Minimal APIs were introduced in .NET 6 to provide a more minimal getting started experience for ASP.NET Core. It allows you to create lightweight, concise APIs with minimal code and configuration. They are ideal for microservices and apps that want to only include minimum files, features, and dependencies in .NET Core. In this video, we will learn more about it and see how to create a minimal API with ASP.NET Core. So let's get started. There are two approaches to creating APIs, a controller-based and a minimal API. Controller-based APIs are the traditional way of building web APIs in ASP.NET Core. They use classes that derive from controller base and define methods that handle requests. Controller-based API supports features like model binding, application model, and view rendering. Minimal API are a different way of building web APIs with .NET Core. They use lambda expressions or methods to define endpoints and handlers. Minimal APIs are designed to be simple, concise, and flexible. They hide the host class by default and rely on extension methods for configuration and customization. But when to use them? Here are a few situations when it can be considered. When you are building small and simple APIs or microservices, minimal APIs can be helpful to reduce the boilerplate code and make your code base more concise. It can also be useful for prototyping and rapid development because they allow you to quickly get an API up and running. If your application's main focus is to provide lightweight services with minimal overhead, minimum APIs are a good choice. It can also be useful when building APIs which just serve data to a single page application like Angular, React, or Vue. It can help you keep the API code concise and easy to maintain. Also, when you need to create simple HTTP endpoints for purposes such as handling webhook callbacks or serving static data, minimal API can be considered. It can also be great for teaching and learning about API development in .NET as they are simple concepts and it makes easier to understand the core principle. But there are few things to be careful about. Minimal APIs are intentionally minimalistic, which means they lack some advanced features which are available in traditional controllers like model binding, validation, and complex routing. If your API requires these features, minimal API may not be the right choice. As your application grows and requires more advanced features, you may end up adding complexity manually, which could counteract the initial simplicity with minimal API. Debugging might also become slightly more challenging due to their conciseness. Traditional controllers with well-structured MVC patterns can provide more organized codebase. Now, since minimal APIs are relatively new, community support and documentation might also be less compared to what is there available for a well-established MVC approach. It is essential to carefully consider your project's requirements and complexity before choosing between minimal APIs and traditional controllers. You can even use combination of them in the same project if that suits your need. So enough of talk, let's build some minimal APIs. Let's start with creating a project. I assume that you have already installed ASP.NET and web development workloads along with your Visual Studio. So let's select web and ASP.NET Core empty. That's the project which we will select. Let's click next and call it as minimal API. We'll keep the framework as .NET 7 and we'll disable Docker for now and click create. So by default, it has created an endpoint for us and which is the default endpoint and it returns hello world. Let's just run this and see. So hello world is displayed in the browser and just by our program.cs we have a minimal but a complete application which is up and running and it is able to make a get request or it's able to process our get request which we have done through the browser. Let's come back to our application and add a NuGet package. So let's come to manage NuGet packages, and we will add entity framework core dot in memory. So as it mentions, this is an in-memory database provider for testing purposes. We don't want to deal with the hassle of creating a DB right now, so we can just use this in-memory package and perform all our entity framework operations. So it will install all the required dependencies. Let's add new folder for models and create a model, and let's call it blog post, and we'll have few properties in it. So we have ID, title, the content, whether it's published or not, when it was created, when it was updated, and probably let's have one more called published on. And now let's create another class which will be our DB context. Select, call it blog post DB context, and we will derive it from DB context. DB context options, and let's have options, and we'll have the DB set for our blog post, and call set of blog post. We don't need this. Now let's come back to program.cs and need this now. So let's add dependencies for our DB context. So add DB context, and we have blog post DB context options, use in-memory database. So this will use the in-memory database instead of actually connecting to another database. And let's add this as well, database developer page exception filter, and for this we will add one more package, that is diagnostics for entity framework code. This is not mandatory as such to put for now, let's have it. And then we have builder.build to build the app. Now let's set up some minimal endpoints. So in minimal API, as I mentioned earlier, there are no controllers. So whatever are your API endpoints, you are defining it using lambda expressions, and then you have handlers defined for those lambda expressions. So we just have minimal setup and we perform the actions. So first let's have a get endpoint where we'll just get all the blog post. So let's sync. In a normal controller scenario, we would ideally inject a service or a DB context into the controller so that we can use it in the action methods to perform different operations. Similarly, here you can inject them into the handlers itself. So if you come to the map get method, we have the first parameter is the pattern. So that is the root pattern which you have for your endpoint, and then you have the request delegate or the handler which will be fired when this endpoint is hit. So when we are defining this lambda expression, we can also define the services which we want to inject into the method when it is called. So here we want our blog post DB context be sent in to the method, and here we can just do context dot blog post dot to list async, and that's it. So we have our first endpoint to perform the action. So let's try running it and see what we get. So now, since we don't have anything in our blog posts yet, so nothing is displayed on the screen, but we don't have any errors. Let's also probably have another one which is to get by ID. So if you see, the root pattern is still the same which we would have used with traditional controllers. So here we have the ID, and we would want that ID to be passed in as part of this method. And in the context, let's do find async with the ID. Blog post dot find async, and here we can do blog post blog, and if it is true, then we want to return results, which is like we have I results, I action result in traditional controllers, and as okay we can return the blog object, or if it is not true we can say not found. So if we have a look at the results class, so it's like a extension method class where all these extension methods are implemented. So it is a results helper class, and it simplifies the process of returning the responses based on the HTTP status code we want to return. So like if we want a success result, we can use OK and pass in the object like we have the OK result in traditional controllers. So this result class works as a helper for this purpose. So if it's found, then we have OK, otherwise we return as not found, and it returns a 404 status code along with the result. Let's add another method for adding a new item. So let's create a post method. Okay, map post, and we will have the same endpoint blog post but with as a post method. We'll have async, we'll have a blog post blog, and then we'll have the blog post db context. Now we have more lines of code, so we have context dot blog post dot add. We have to add the blog and save changes async, and after that we can return results dot created blog posts slash blog dot id, and the object is this. Now what we did here was by returning the results with the created extension method, we are trying to make it REST compliant and conforming with the REST norms, where in the response header we will have details of how to fetch the blog object which was created. So now to test this out, let's open Postman and try to access these APIs. If you don't have Postman, you can install Postman from here, and the link is displayed on the screen. And if you are not familiar with Postman, Postman is an API platform for building and using APIs. Simplifies testing of the APIs. You can use it to hit your endpoints using your test data, and it can help you create better APIs. So let's open Postman. So I have started my application and I have the Postman open, and now if I do get on the blog post endpoint, you can see there is an empty array, and let's put the same on other endpoints. Now let's come to the post endpoint and create a new post. So for now in our class we had quite a few properties. I am just putting the title and content, and let's see what happens. Let me send, and you can see it gave me the response. So this is the ID which was created for the blog post. Other properties are set to default, so let's probably change that. But before that, now let's do a get on our blog post, and we get an array, and since we only have one blog, we have that as the result. If we do a get by ID and I pass ID as 1, we get a blog, and if I pass say 2, then the status is 404. Similarly, if we come to the create blog endpoint, you can see the status was 201 created, because if you remember we had called results.created extension method which sets the proper HTTP status code. One more thing it does, it adds this location header and also gives out the path where you can access this blog post, and it makes it REST compliant. So I had talked about this in another video where we had discussed about API versioning, so you can check out this link on the top if you want to watch that video. Let's come back to our post method and make few changes. So what we want to do is, when we are creating, we want to do datetime.utc now. Same we want to do with and publish date. Let's make one change. Let's make it nullable, and we don't want to touch the publish flag as of now. So that's it. Let's try running it again. The API is running, and let's create the blog post again. Now the benefit of using in-memory database is that we can use the same data, because now since I've restarted my application, my in-memory DB is gone and it's a fresh one. So let's just send this across, and now in my response you can see the created date is set, updated is set, publish is set to null because we made it nullable, and we can change it later. Let's now add another endpoint which will modify our existing blog post. So I'll just add the code to make it to just jump ahead. Now I have updated the code to add few more methods. So I have added a put method which would update the blog, and here we are finding the blog by the ID, and if it is not found, we are returning not found, that is 404. Otherwise we are updating the title, content, and also we are setting the updated date to the current time to mark our updated status. We are ignoring whatever is coming from the date, created date. Also, if it's marked as published, and if the published date on the existing blog, if it wasn't published, or we could have checked the published flag as well on this one, but yeah, again depends on what you want to check. We can, so I'm setting the published flag, the published date to the current date, and then saving the entity. Similarly, we have another endpoint, a post method, just to publish the flag, so we just sets the publish flag. And finally we have the delete method which deletes our blog post. So that's with this. Let's just test this. Let's create our entity again. So we have created it. Now let's just update it in the update blog. So we'll again query it with by the ID, and we are specifying the properties. So generally by HTTP specification, we should send all the properties of the object as part of put. So put is meant to replace what is there in the DB. If you want to do a partial update, patch is what you should use. So we haven't defined a patch method, so we'll use the put and define all the properties. I want to keep it as still as not published, but I've changed my title a bit, and also I've added something to the content. So now let's see what happens. So the response is 204, no content, means it was successful, and in the method we have specified it to return no content. Let's come to get blog by ID and just request it, and now you can see the created and updated date is different because we have updated it once. Let's come to publish and set it as published. So this one is a post request which just takes the ID, nothing else, and we got a successful response. Now if we get the blog, we can see the publish is set to true, and we have a publish date as well. Let's create one more blog, call it blog 2, and it is created with ID 2. So now if we do get blogs, you can see there are two entities, and let's go and delete one. So we'll delete the one with ID 1, and now if we do get blog, it should have only one. So with this, we have our minimal API. We haven't defined any controller, we have just defined some delegates or lambda expressions, and we have a working API which we can integrate with our application. We can also group. If we want to group it, we can call map group, and we can move this part here. We can call it API, and let's just replace all of this references. Use that. Now we don't need to have these references for the root. Obviously in this response we will need to mention because we have to define the whole path, but the rest of the places we don't have to repeat that part of the root, the prefix, and we can define from the reference of this group. So this way, if you have 2-3 sets of APIs, you can group it one by one and it becomes more readable. So let's try running it and see that we didn't break anything. We have our app running again, and let's just send this, and it is working. So now the ID 1 is assigned to this, and it is working now. Let's call all get, and it is running properly. So this way you can create a minimal API with very much less hassles and with very less dependencies. And it's great when you want to kickstart something very quickly, do some POCs or test out your APIs. It gets you up and running really quick. And there you have it. Remember, minimal APIs are fantastic for small to medium-sized projects, offering simplicity and ease of development. However, for large, more complex applications, traditional controller based approach might be the way to go. Ultimately, the choice between minimal APIs and traditional comes down to the balance between simplicity and complexity and the specific requirements of your application. I hope you found this video useful and that it helps you in your API development journey. If you have any questions or want to see more content like this, feel free to let me know in the comment section below. Don't forget to like this video if you found it useful and subscribe to stay updated with more great content. If you want to learn about configuration in .NET, you can check out this video. You can also find something interesting to watch next here. Thank you for watching and I'll catch you in the next one. Adios.